everyone, here is your classwork for Monday and Tuesday, the 21st and 22nd of September. This might go into Wednesday depending on how long it takes us. We'll see. We're continuing with properties of operations now that we know how to multiply, add, subtract, divide exponents, because we need to know how to do that to do all these other things. So a couple quick reminders before we start. Drop dead date is on Friday, and also make sure you've turned in your exponents and multiplication homework. Now, before we jump into the classwork for today, if you were able to go pick up all the math stuff that was printed for you for the Monday pickup, grab that stuff. You'll need some of it today. And also grab your notebook. You're going to need your notebook. I would encourage you to take notes, even if what I have in here is already printed for you. There's examples of stuff that we'll go over that aren't printed. So those are always a good thing to write down. Okay. What I want you guys to do first is solve this problem. 18 times 5. Now, what I want you to do is you're going to have to do it by hand. By hand. So you can do this like long multiplication style. You could turn it into like a repetitive addition problem. You can do this visually, however you want, but you have to do it by hand. Okay, so pause this, do it real quick, and then unpause when you're ready. All right, I'm going to assume that you paused it, tried and words, right? Tried to do it by hand. So I'm going to show you some common visual and other ways to do this by hand that I've seen before. Now I've changed all the names. These are just random names. But here you see different representations of how to do this problem. Neil, for example, broke down 18 times 5 into 9 plus 9 times 5, right? 9 plus 9 is 18. So basically what he did was 5 times 9, which is 45, and then 5 times 9, which is 45, and added those together, right? Sammy did something similar to that. What Sammy did was he or she broke it down into 10 plus 8. 10 plus 8 is 18, right? So different way to break 18 down. And then multiplied those numbers by 5. So 10 times 5, and then 8 times 5. Okay, now Jamie here looks like they thought it might have been easier to multiply 5 by 20, right? So instead of doing it by 18, multiply it by 20. So 20 times 5 is 100. Okay. Now, because they added that extra 2, they then did 2 times 5, which was 10. So if we subtract that extra stuff from what we got here, we get the correct amount. Okay. So again, there's various ways to do these, whether you're doing them just like this mathematical way or doing it visually or both. Okay, there's various ways to do these problems by hand. What I want you to do now that you've seen kind of those examples and also done one by hand, I want you to do one more of these by hand. Okay, so you're going to do 22 times 7. Solve 22 times 7 in as many ways as possible, visually or written out. So this would be like a visual, and that would be like written out. Okay. I want you to time yourself. Actually do it, let's say 3 minutes. Okay. Time yourself for 3 minutes. Try and do as many as you can. Okay. Just to get our brains working. And I will give candy to the ones that I feel are creative. Okay, so if you feel like you have a creative one, send it on over. Okay, and I will ship some candy home somehow. Okay, pause it, get to work for 3 minutes. Okay, so I'm not going to actually go over different ways of doing this one just because I want to see what you guys came up with without me going over anything. Okay, so I'm not going to go over the answers to that, but I do want to see it. So actually what I want you to do is Maybe if you're able with technology, take a picture of what you did of work and either email it to me or post it on the Google Classroom with this video. Okay, so you can like comment on the materials with this video. Okay, all right, let's move on. Here's a challenge for you. So let's say we had 1 plus 2 plus 3 plus 4. If we were to add those up, we get a sum of 10. What I want you guys to try to do is generate the number 110. So try and get a sum of 110 or sum or product. So an answer of 110 by making repeated use of the numbers 1, 2, 3, and 4. So those are the only numbers you can use. Okay, only 1, 2, 3, and 4. You can use addition and you can use multiplication only. Okay, that includes like parentheses, right? Parentheses are basically multiplication. So no dividing, no subtracting, no exponents, square roots, anything like that, and no juxtaposing. So if we're saying that you can use the number 1, you can't just say 1 and 1 make 11 because they don't, they make 2. Okay, so no juxtaposing. So try that. Come up with at least one way. And again, I want you to either type it in a comment on this assignment on Google Classroom or comment it as a picture. Okay, but I want to see what you guys do. Okay, lots of people come up with awesome creative answers for this. Okay, so pause the video, do that, come up with at least one way to do it, and then comment on this Google Classroom material assignment, I guess you could say, and then come back. And again, I'm not going to go over answers for this just because I want to see what creative ways you guys come up with without spoiling anything. Okay, let's take a look at this question. I know this all seems kind of like random right now, but I promise it will all come together in just a minute. Okay, so let's talk about distributive property for a second. Basically, distributive property is saying that if we have something outside of parentheses and something inside parentheses, this right here, the something outside parentheses next to something inside parentheses, that means multiply. So basically what we're doing is distributing that multiplication to everything inside of the parentheses. So that's kind of the basic gist of distributive property. We're going to go over tons of examples with it, so don't fret if you don't understand it quite yet. But I want you guys to think about this question. Is the expression 2x plus 3x an application of the distributive property? So in other words, can we get 2x plus 3x using the distributive property on some expression? So basically, you guys need to work backwards with distributive property. Okay, if you've paused it, tried to figure it out, awesome. If you're just like, I have no idea what she's talking about, no worries. I'm going to give you this example. So we have 2x plus 3x, and we want to know if we can get that answer, that expression, by using distributive property on some other expression. Okay, to do that, we need to work backwards. Okay, when we work backwards from distributive property, it's called factoring. Essentially, instead of multiplying, we're dividing with factoring. Okay, so it's the opposite, right? If distributive is multiplying, factoring is dividing. Okay, so what we're going to do is with factoring, and we're going to go over factoring a lot more later in the year, but this is just kind of a brief introduction. What you're going to do is notice the common term. Okay, 2 and 3 are not the same, but both of those terms have the variable x in them, 2x and 3x. Okay, so we're going to factor out or divide x out of that expression. So kind of the long way of showing what we're doing here is we're dividing by x. 2x divided by x would be 2 times 1 because x divided by x is 1. So you're getting 2 times 1 with x outside. Okay. That's kind of like the what's actually happening when we do this. Okay. But again, if when we're distributing, we kind of multiply it to both of these things. So it'd be, if instead of a times c plus x, it'd be a times c plus a plus x, or sorry, plus a times x. So essentially, instead of going this way, we're going to do the opposite and carry that x out. So we're factoring it out, we're dividing it out. So the x is going to end up outside some parentheses. Anything that wasn't an x is going to stay the same. Okay. Now we're just going to simplify. Okay, combine any like terms. Oh, my God. Combine any like terms that we can. It's nap time. Okay, so 2 plus 3 is 5, right? And we know that x times 5 is the same thing as saying 5 times x, which was that answer that we got. So yes, this is an application of distributive property because from this expression right here, if we were to distribute that x, we get 2x plus 3x. Okay, and there's a roundabout way of seeing if you guys know what factoring is. And again, this may all seem like totally random right now, but we're going to get there. Oh, that's just the what we just did. Okay, so let's talk about distributive property. Again, I kind of went over a brief explanation where if we have something outside parentheses and something inside parentheses, basically we're taking whatever's outside and multiplying it by everything inside. Okay, so this would end up being a times b plus a times c. Okay, hopefully that rings a bell from the last couple of years. So we're going to get into some pretty difficult distributive property problems. So I want to go over two key ways. There are more ways than two, but we're going to go over 2 key ways of how to solve this. I don't care which one you use, if you use the box method or distribution method, as long as you understand one of them, okay, and you can show your work with one of them, that's what I care about. Okay, so if the box method works better for you because you like the visualization of it, awesome, go with that way when we're working on problems. If the other way works better, then do it the other way. But I want to show you both so you can kind of choose which way you think works best for you. Okay, first thing I want to point out, if you ever see something like this where you have some number variable plus some number variable and it's squared, it means you're basically taking that same thing and multiplying it by itself, right? We know that 2 squared is the same thing as 2 times 2, right? So if we had a squared, same thing as a times a. So if we have something in parentheses, a plus b, it'd be the same thing as saying, or sorry, squared. It'd be the same thing as saying that same grouping, a plus b, times itself. Okay, so that's kind of what this is saying right here at the top. I'm going to erase that just so we don't get confused. Okay. Okay. So I wanted to point that out because a lot of times people will think that this right here, a plus b squared, means this, but it is not the same. They will not get you the same answer. Okay. and we will go over why that is. Okay, with box method, I'm going to zoom out. We're going to do a couple examples with this. So, box method. Okay, with box method, I'm going to write out a few steps, then we'll go over a few examples. I just want to write it out, so if you want to like screenshot it or something, or if you want to take notes on how to do it, great. Okay, so with box method, basically, you're going to place each grouped, by grouped, I mean parentheses, grouped expression. I know how to spell Abrams. Expression on different sides of a box. And I'll go over what that looks like. Then you are going to multiply the sides of each box and write the product meaning multiplication answer. Then you would want to combine like terms. Again, I'm writing this all out and then we'll actually go over what all this means. Combine like terms if there are any. If there's not, you can't combine them, so just leave it. And then write out the, I know my handwriting's not the best on while I'm writing on this tablet, but okay. Write out the expression. If term, so if the term, the product term is positive, you add. If term is negative, you subtract. Okay, now let's go over what all of that means in an example. Okay, box method, let's do this. Okay, I'm going to start by just doing the generic one with variables, just so you can kind of see what it's supposed to look like, and then we'll go over examples with numbers and variables, which you will actually be using. Okay, so the general rule for this, whoa, what happened there? Let's say I have the expressions a plus b, and we're multiplying it by c plus d. Okay. The box method is saying that we need to basically make a box, okay, and put each of the grouped expressions on different sides of the box. So what I mean by that, because there's two terms in each expression, we are going to have a 2 by 2 box where we have a plus b and c plus d. So each grouped expression is on one side of the box. Okay, right, and then this one is over here. That's what I mean by put it on each side of the box. Now we'd put lines in those boxes because it's a 2 by 2 box. You can even extend those lines if it kind of makes a little more sense to you. Okay, like that. Either way is fine. Okay, now we're going to multiply the sides of each box and write the product. What I mean by each side, if we're talking about this box right here, we're going to be multiplying this side by this side. Okay, if we were talking about this box over here, we're multiplying it by this side and this side. Okay, so basically it's the top side of the box. Ooh, let's do that in pink. The top side of the box times the left side of the box. Okay, so that's kind of what we're doing there. If it was this box, we would be doing, I'm writing this out in like as much detail as possible, so that way when we get to other more difficult problems, you can look back here if you need to. That box will be that one times that one. So it's the top side. Maybe I should write this. Multiply top and left sides. That's what I mean there. Okay. So much information. Okay, let's do this. And then we're going to write the product. So, need a color we haven't used. So we have a, let's use purple, because red and blue make purple, and this is kind of red and blue. Okay, so the first box, we have A times C. Now, it doesn't matter what order you write it. It could be CA or AC. Either way is fine. I tend to do the expression on top, those variables first, but it doesn't really matter. Okay, so A times C would just be AC. B times C would be BC. A times D would be AD or DA. And then B times D would be BD or DB. Okay. From here, you would check if there's any like terms. Like terms meaning same variable to the same power. Now, none of these have the same variables. So we have AC, and we do have another one with A, but it has a D instead of a C. So they wouldn't be like terms. Okay, so none of those are like terms. So now we would simply write out the expression. Since they're all positive, we're adding all of those terms together. So you can start in any order. It doesn't really matter. I tend to start with this one. This one will typically be last. So we would have AC plus BC plus AD plus BD. Okay, and again, none of those are like terms, so this would be the most simplified we can get. That's our answer. Okay, so that's the gist of the box method. That kind of made it seem a little complicated, so we're going to go over a couple examples together on here. So let me just scoot down a little more. Okay, so let me write example A. Example A. We are multiplying 5n plus 6. Oh no, we have numbers and variables. It's fine, guys. We'll get through it. Multiplied by 5n minus 5. Okay, so we're going to put each of these expressions on their own side of a box. So we're going to have 5n plus 6. And then we have 5n minus 5. The reason that is a plus and that's a negative is because there we're adding, there we're subtracting, so negative 5. Okay. Now I'm going to draw my little box so I can keep things straight. Okay, let's do this. Ooh, I meant to do those in, hang on, in a different color, just so you can see exactly what is happening. Okay, so the first box, we have 5n times 5n. Okay, I'm just going to 5n times 5n, just so you can look back and see what we're actually doing. So 5n times 5n. Well, first you multiply the coefficients. So 5 times 5 is 25. And n times n would give us n squared. Next box, we have 6 times 5n. Okay. Now we multiply the coefficients first. So 6 times 5 would give us 30. And then n, we would just, there's no other n, so it would stay n to the first power. Okay, next we have 5n times negative 5. I'm just writing what we're actually doing in the box just so you can see it. I don't normally do that, but just an example for you. Okay, so 5n times negative 5, so we're going to multiply the coefficients. Negative 5 times 5 would be negative 25. Okay, and n stays the same. No, I switched colors. Okay, and then the last one we have 6 times -5. So positive times a negative is a negative, so we'd have -30. Okay. Combining like terms. One way the box method is kind of nice is typically the that makes it look messy. Oops. Typically the diagonal boxes here. Trying to highlight it without covering stuff. Typically the diagonal boxes with the box method will be like terms. So for example, with these ones, we have coefficients and we have variables. The variables are the same and they're raised to the same power. They're both n to the first power. So those ones we can actually combine. So 30n plus a -25n, which would be the same thing as saying 30n minus 25n. That's going to give us 5n. So we'll keep that in mind. Now let's start with the top box. We have, that one doesn't have any other like terms. There's no other n squareds. So we would say 25n squared. Next we have 5n, it's positive, so we would do adding. And then the last one is -30, so we would subtract 30. Okay, so there's your answer. Okay. Now, I'm going to show you one more, and then I'll let you do one by yourself. Don't worry, at the end of the lesson, you'll be doing lots by yourselves, but just do one for now. Okay, so let's do example B. Line here, example B. Okay. All right, let's get to this. Let's do a monomial, so a single term multiplied by a binomial, so an expression with 2 terms. Switching it up from x, we're going to use y. Not y, v. I don't know why I said y. Jim. Sorry, my dog was trying to get in the garbage. Okay, so we have a monomial multiplied by a binomial. We have 7 times -5v minus 8. We're going to have 7, that's one side of the box, and that will be the other side of the box. So if you have just one, you just have one column, right? So, and then over here we have -5v and minus 8. Draw our little grid to keep us organized. Okay, here we go. 7 times -5v, so multiply the coefficients, we'd have -35v, -35v, and then 7 times -8 would give us -56. There's no like terms, 56 doesn't have a v, so we can't combine them. So from there, we would just write out our answer. -35v minus 56. And voila, you are done. Okay, so hopefully that made sense. If it didn't, let me know and I'll walk you through more examples. But what I want you to try now, try this one by yourself. Try this at home. So you're going to do 6v multiplied by 2v plus 3. Okay, so pause the video, do that, and then unpause it, and we'll see where you're at. Okay. Okay, I'm assuming you tried it by yourself, you're coming back. So let's walk through how to do this box method style. All right, so we have 6v for one side of our box. The other side we have 2v plus 3. Super exciting. Let's do this. Okay. I don't know why I have that extra column there. Come on, Miss Monson, get with it. Okay. 6v times 2v, multiply the coefficients. 6 times 2 would give us 12. V times V would be V squared. Then we have 6V times 3. 6 times 3 is 18. And then V, we just add on there because there's no other V's we're multiplying by, so it's still V to the first power. Now, none of those are like terms, right? One of them's V squared, the other one's V to the first power, so they are the same variable, but they're not raised to the same power, so they're not like terms. We can't add them. So we would just, from there, write it out. 12V squared is positive, so we just have 12V squared. 18V is also positive, so we would say plus 18V, and there is our answer. Again, if that didn't make sense, let me know, and I'll help you out. Okay, let's go back here. Couple things I wanted to point out. You probably noticed that I was writing those in a certain order when we wrote out the answer. That order is called standard form. Standard form. Standard form means you're ordering terms with variables from greatest power to least power. The constant will always be last. If there's 2 variables in the term, you'll list those before single variable terms. So here's kind of an example of that. Right, we have x and y in this one. No other ones have x and y, so that expression would go first, that term would go first. Now we do have 2 with just x, but this one's x to the second power, so it has a greater power than x to the first, so that's why that is next. Then this comes before -7 because -7 is a constant, it doesn't have a variable, so that is last. That's kind of what I mean by standard form, right? And greatest power to least power. Generally in this class, we'll just have 1 variable, but I wanted to let you know what to do in case there are multiple variables. Okay. So I showed you box method. Now we're going to talk about just basically pure distribution method. So no visuals this time, really. Okay. So with distribution method, I'm sure you've seen like the little arrow things that you've done in maybe previous years, right? Whatever's outside the parentheses, you're multiplying by both things inside it. So you're distributing that 8 to the x and the 8 to the 3, right? But I'm going to go over when we have more than just a monomial, so just one term multiplied by the binomial, okay? Okay, which example did I want to do? All right, let's do this. I'm going to do the general one first, and then do some with numbers and variables. Took up a lot of space over there. Math. Okay, we'll do that because you've already seen the other. So we are doing this stuff over here. Okay. All right. Okay. So distribution method. Okay. Here's your little tune for it. Distribution method. Okay. So essentially what you're going to do here is multiply each term in one expression by each term in the other one. So I'll write that out. Multiply each term in the first polynomial expression by each term in the second polynomial. Okay, what I mean by that, let's do it. We have, again, I'm doing the general one first, so we have a plus b, and then we're going to have c plus d. So same problem we did on the box method one for the general way to do this. Okay, so we're going to multiply each term in the first polynomial. So we have a, and then we have b, by each term in the second polynomial, c and d. So the kind of in-between step I'm going to write out first, and you don't always have to do this. I would recommend doing it for the first little while you're working with distribution method and multiplying binomials, but you will be able to skip it later on when you've got the hang of things. Okay, so first step, we would have A, and we're going to multiply it by the second expression. So just the whole thing, write the whole thing out. Next, we have B, and it's positive, so we're going to say plus B times that whole expression. Okay. Now we're going to do it just like if we were multiplying a monomial by a binomial. So we're taking that A, multiplying it by both things inside, and then the B by both things inside. Okay. So we have A times C, which would be AC. And then we have a positive AD, A times D. So A times D. Then we have B times C, and they're both positive, so positive BC. And then B times D, they're both positive, so it would be plus BD. Here you would combine any like terms if you have any. We don't have any here, so that would be our answer. You can go back and compare it with the one we did with the box method. It'll be the same thing. Okay, could be in a different order, but in this case, order doesn't really matter because they're all variables raised to the first power. Okay, so we're going to try a basic one together first. Let's do, which one do I want to do? I've got one for you. I'm going to go over two examples and then I'll let you do one. Okay, so this first problem, so example C is where we're at now. We are going to multiply 8p minus 2 by 6p plus 2. All right, let's do this. So first thing we're going to do is take each term in the first one, so 8p, and we're going to multiply it by the whole expression, the whole second expression, so 6p plus 2. Then we would have minus 2, because it's a negative, so minus 2, it's supposed to be minus 2, multiplied by the entire second expression, so 6p plus 2. Okay, now let's do this. We're going to distribute distribute the 8p by the 6p, so 8 times 6, remember multiply coefficients first. 8 times 6 will give you 48. P times p will give you p squared. Then we would do 8p times 2. So 8 times 2 would give us 16, and just p because there's not another one. And now we have negative 2 times 6p, so negative 2 times 6 first, so coefficients first. Negative 2 times 6 would be negative 12. Then we have, just carry down that p because there's not another one we're multiplying it by. Then negative 2 times positive 2 will give us a negative 4. Okay, from here you'd want to combine any like terms. So again, like terms would be the same variable raised to the same power. All of these are dealing with p here, but there's 1 raised to the second power and 2 raised to the first power, right? So these are the like terms that we need to combine. So since this isn't changing, I'll just carry it down for our answer. That was a weird p. Okay. And then 16p minus 12p. So basically we're subtracting the coefficients. 16 minus 2 minus 12 would give us 4. Right, and it'd be positive, so 4p. And then we have minus 4. And there is our answer. Okay, so again, some people like this method better. It just makes more sense to them. Some people like the visual box method better. Either way is totally fine as long as you are comfortable showing your work on how to get the answers. That's what matters. So I'm fine with you doing either one. Let me go over one more example on this one, then I'll let you do one. And this one's going to look a little hairy compared to the one that we just did, or the ones that we've done already today. Example D. This one, drum roll please, we're going to have a trinomial of 6n squared minus 6n minus 5. So trinomial because there's 3 terms in that expression. Whoa. Okay. And we're multiplying that trinomial by another trinomial. Ah, it's okay. Don't fret. Don't fret. I got you. I got your back. All right, let's do this. Same method we did before. You're going to take each term in the first polynomial and multiply it by the second polynomial. So 6n squared. And we're going to multiply it by that whole entire thing so we don't mess up and skip something. Then we're going to have negative 6n, or minus 6n, multiplied by the whole second expression. My dog just walked into the house after picking an apple off her tree, and he's eating the apple. It's kind of crunchy. I don't know if you can hear it. Okay, and then minus 5. Sorry if that distracted you, but it distracted me. Okay. There we go. So we have each term in this first polynomial multiplied by the second polynomial. Now we're actually going to distribute those. So essentially we're doing 6n squared times each of those numbers. So 6n squared times 7n squared. We're going to do coefficients first. So 6 times 7 will give us 42. N squared times n squared. Remember, you're going to add the exponents here. So it'd be n to the 4th. Now we have 6n squared. I'm sorry, I forgot an n here. There's supposed to be an n there. My bad. Okay. Don't worry, I'm with it. All right, 6n squared times 6n. So 6 times 6 first, coefficients first, be 36. Then we have n squared times n, which would be like n to the first power. So add the exponents. 2 plus 1 would be 3. So n to the third power. Then we have 6n squared times negative 5. So negative 5 times 6 will give us negative 30. Okay. Whew, this is a lot of steps for a big problem. Again, the more you do this, you're going to be able to skip some of these middle steps, and you'll be just fine. But gotta get the hang of things first. Whew, another big yawn. Sorry. Okay. Here we go. Negative 6n times 7n squared. So we have negative 42. And then n to the first power times n to the second power give us n to the third power, right? Add the exponents. We have negative 6n times positive 6n. So you would get negative 36n squared. N to the first times n to the first would give us n to the second. Then we have negative 6n times negative 5. And negative 5 times a negative 6 will give us a positive 30. Last group, negative 5 times each of these things. So negative 5 times 7 would give us negative 35. And n squared stays the same. And then negative 5 times 6n. So negative 5 times 6 would give us negative 30n. Negative 5 times negative 5. Beware there. Negative times a negative is positive. So it would be positive 25. Woo! Are we done yet? No! Because we need to combine like terms. Always combine like terms. So let's see what like terms we have here. So you'll notice that there's no other terms that are 42. Or sorry, that nobody cares about the number 42. I care about it. Okay, there's no other terms with n to the 4th power, so that one is going to stay the same. 42 times n to the 4th. Now, we do have we have a couple that are n to the 3rds. So we're going to combine those ones. Combine meaning add or subtract depending on the operation there, which is subtract in this case. So to kind of do this, 36n to the 3rd minus 42n to the 3rd. Okay, so 36 minus 42 would give us a negative 6. So it would be negative 6n to the 3rd. Now we have n to the 2nd. N to the 2nd. Okay, so there's all of our n to the 2nd terms. So let's combine those. I'm going to write them out and then we can combine them. So negative 30n squared minus 36n squared minus 35n squared. So we're starting with the negative and just subtracting more. So I know it's going to be a big negative number. So if we do negative 30 minus 36 minus 35, you can do that on your calculator, or you can wait a second and I will show you what it is. Thought I'd give you a second to try it though. It'd be negative 101, negative 101 times n squared. Now we're down to just n to the 1st power. There we go, n to the 1st power, n to the 1st power. I'm trying to highlight these in different colors so you can see the like terms visually, so you can kind of get in the habit of looking for those like terms and what it looks like when they're like terms. So here we have a positive 30n minus 30n. Well, 30 minus 30 is just 0, and 0 times n is just 0. Anything times 0 is just 0. So those actually just cancel out, so we don't need to write anything down for our answer. And then lastly, we have our constant. There's no other constant, so that one would stay the same. And there is our answer. Now I know that's like a lot of steps and it took a long time to get through that problem, but again, once you get the hang of it, and I'm not like just teaching it word for word, step by step, it's going to be a lot faster. Okay, so don't be scared off by this yet. It's like a puzzle that you need to put together. Think of it like a puzzle. Okay, so that was kind of a hard one. So what I want you guys to do, this one, you're going to do this one by yourselves. So try this at home. You're going to do 2n plus 2 times 6n plus 1. Okay, so pause the video, try it by yourself. Please try it by yourself, okay? And then come back when you're ready. All right, assuming you tried this by yourself, and now I can just go over it with you just to make sure we're on the same page. Okay. We're going to do both of those terms multiplied by the other expression. So let's start with 2n times 6n plus 1. Sorry, I'm kind of like running out of space here. Make sure we know what problem is where. Okay. So organized, Miss Monson. Okay. And we have positive 2 times 6n plus 1. Okay. So 2n times 6n, again, multiply coefficients first. So 2 times 6 gives us 12. N times n to the 1st times n to the 1st. So 1 plus 1 gives us n to the 2nd. Then we have 2n times 1. So anything times 1 is just itself, so it'd be 2n. Okay. And just scoot this over just a little bit. Oh, there's a lot of space there. Hello. Okay. All right. So now I have positive 2 times 6n. 2 times 6 gives us 12 again. 12n, because there's no other n's we're multiplying it by. And then 2 times 1 gives us 2. We're not done yet. We need to combine like terms. Now, there's only one term with end of the second power, so that stays the same. And then we have 2n plus 12n. So both of those have n to the first power, so we can combine those. 2n plus 12n would give us 2 plus 12 is 14. That n would stay to the first because we're adding, we're not multiplying. And then we would have plus 2 because that one doesn't have any like terms either. So there is your answer. Okay, so hopefully that's what you got. If it's not, maybe go back, check your work, and ask me if you have any questions. Okay. Woo! I know this is so much. Please pause the video and take a break. If you haven't already, give yourself a little mental break for a minute. Okay, distributive property, checking your work. Okay, this is super important. When I was writing the key for the assignment that we're going to do, I checked my work on one of the problems and did not do it right. So it's really important to check your work. Get in the habit of it. I know it takes extra time, but it's definitely worth it. Okay, so basically to check your work, I'll just show you with the try this problem. Okay, to check your work, you're going to choose any number for the variable. So choose any number to substitute. I talk so slow when I write. For the variable. Okay, so here we have the variable n. So I'm just going to say that n equals 0. Okay, it could literally equal anything. You could do positive number, negative number, 0, fractions, decimals, anything, as long as n is the same number in all of it. Okay, so what you're going to do is substitute that number in both the problem and your answer. If they equal the same thing, then you're good. So let's do that. Here we have, we're going to start with the problem. So it was 2n plus 2 times 6n plus 1. So I'm going to have 2 times n, which is 0, plus 2. I'm trying to color code it to make it visually easier to see what I'm doing here. 6 times 0, because there's an n there, plus 1. Now we're just going to solve. So 2 times 0 would give us 0. Okay, and then we have 6 times 0, which is 0. So 0 plus 2 is 2. 0 plus 1 is 1. 2 times 1 is 2. Okay, so just substituting 0 in for n and solving. Now we're going to do the exact same thing with our answer. Okay, so we're going to have, oh, hi, Jim. Hi, Jim. My dog just, hey, buddy. Just came up to say hi. Okay, I know you're bored, huh? You don't like listening to math. Oh, hi, Rufio. Okay, both my dogs are, 2 of my dogs are coming up to say hi. I've got 3. Okay, back to work. Okay, so we're substituting 0 in for n. 0 squared. I'm gonna run out of space here. Let's get it right small. 14 times 0, and then plus 2. Okay, so 12, or first we do exponents, right? Order of operations. Exponents. Well, technically parentheses first, but there's nothing in parentheses. So exponents next, 0 squared is just 0. 0 times 0 is 0, right? And then 0 times 12 would give us 0. Right? 14 times 0 is 0 plus 2. So 0 plus 0 plus 2 is 2. Since these answers are the same, we did it right. Bravo, team. Bravo. Jen, get down. Trying to get to some food on the counter. Yay for videoing from home. Okay. All right, so check your answer. It's very useful. Even I made a mistake, and it was useful for me to check my answers when I was making the answer key. Okay, distributive property. Why is it useful? Why should we learn this? Well, because you can wow your family and friends and dates with multiplying giant numbers without a calculator. That's just one reason. Best reason, I think, but it's just me. So this is basically what we were doing at the beginning when we were doing the 18 times, what was it, 5, and then 22 times 7. This is the same thing. They were all using distributive property in some way or another, right? So let's take this one for example, 97 times 4. We can break 97 down into different parts, right? You could do 90 and 7. Okay, that would be one way to do it. So you could write it out as 4 times 90 plus 7. That's a lot more manageable than 97, right? Who knows 97 times 4 off the top of their head? No one. Or you could do it like with the box method. So 4 times 90 plus 7. You could even break it down even more. So you could do, like, instead of 90, you could do 10 plus 10 plus 10, etc., right? And do 4 times all of those and then add them all together. But just so you can see what I mean. So 4 times 90, that's kind of a big number. Let's just focus on 4 times 9. Okay, what is 4 times 9? Anybody? Anybody? 4 times 9 is 36. 36. Now we would add the 0 because it's actually 90, not 4 times 9. So 360. And then 4 times 7 would give us 28. Then what you would do, same as when we were writing out the expressions, you would add those. This is a lot more manageable than 97 times 4, right? 360 plus 28, 360 plus 20 would be 380, and then add the 8 there. 388, and there's your answer. We just did 97 times 4 like it was a piece of cake. Let's do 311. 311 times 7. That one's even more impressive. 311 times 7. All right, different ways to break 300 up. There's lots of different ways, but I'm going to do 300 plus 11. Again, you could do like 100 plus 100 plus 100 plus 11, because that would all add up to 311. But I'm just going to do 300 plus 11. Then we would multiply, so distribute, right? Distribute. 7 times 3 is 21. Add the 2 zeros. 7 times 11 is 77. Combine those, we get 2,177. Woo! Again, you could do the same thing with like 17 instead of 7. So if it was like a double digit there, right? Instead of 17, you could say something like, if we did our box method, right? 17, we could split 17 up by doing 10 plus 7. It's just so cool. I love doing this. Like, I'm terrible at doing arithmetic just in my head. But when I like break it down like this, I can do like huge giant things. It's just very what's the word? Confidence boosting. Powerful. It's just kind of powerful doing this. And I know that sounds super cheesy, but that's okay. So if we had 17 times 311, we could do it like this, right? So 10 times 300, well, 1 times 3 is 3, and we have 3 zeros. 300 times 7, 7 times 3 is 21 plus the 2 zeros. 10 times 11. Oh, sorry, I just got a leg cramp. Had to readjust. Okay, 10 times 11. We're good now. Oh. And then 11 times 7. And then we would just need to add all of those numbers together. And you're like, this is a lot of work just to impress someone. Yeah, but it's pretty dang cool. You just did 311 times 17 without a calculator in like 30 seconds. That's pretty cool. Okay, so it's useful for a lot of different things, math class included, because we're going to be doing a lot of stuff like this. But it's just, I don't know, it's kind of empowering, I think, to be able to realize that you can do that without a calculator. Whew. Okay, break time. Take a break. We're going to talk about two other properties real quick, then do some practice. Associative property. We kind of already went over this in the Back to Basics unit. But let's just kind of go over it again really quick. Associative property is all about, the keyword there is regrouping. So think about the word associate. Associate means like, who do you talk to and what groups do you communicate in and whatever. So associate means group. Basically, you're communicating in groups. Who are you friends with, right? And we have different groups, right? So we can always regroup. So maybe I'm hanging out with my family group one day and then my friend group one day. So think about associate and group. So associative property is all about regrouping. What do I mean by that? Well, grouping symbols in math would be like parentheses, brackets. You could have the like curly brackets. So we're basically regrouping or moving the parentheses around. And it basically is saying that we can move those around. If we're adding everything, we can move them around and we'll still get the same answer. Or if we're multiplying everything, we can move the groups around, regroup things, and we'll still get the same answer. So there's some examples for you right there. So in I'll just do a separate one. Let's say we have 5 plus 6 plus 7. Okay. And basically we're regrouping, we're not ordering, so the numbers are going to stay in the same order, 5, 6, and 7. Okay, but instead of 6 and 7 in parentheses, I'm going to put the parentheses over 5 and 6. So again, order doesn't change. I'll write that down. Order doesn't change if we're just doing associative property. Okay, so keep that in mind. And basically we're saying that this equals this. Well, let's prove it. 6 plus 7 is in parentheses, so order of operations, we do that first. 6 plus 7, Jim, gives us 13. Plus 5 is 18. Sorry, yawning again. 5 plus 6 over on that side gives us 11. Plus 7 gives us 18. So we get the same answer, and you can do this with multiplication too. The key thing is everything has to be adding, or everything has to be multiplying for it to work. If you have adding and multiplying and dividing and subtraction in there, it's not going to work. Okay, so keep that in mind. Now, commutative property is all about reordering. So remember, associative property, we said we don't reorder. Well, commutative property is the reordering part. Commutative property is reordering. Reordering. So think of communication, the word communication. Communication, we're talking or writing. Got distracted. Communication. We can say things. This is just to help you remember which one's which. So we can say things in different orders, and the meaning is still the same. So for example, I could say the sentence, black is my favorite color. Okay. I could also reorder those words and say my favorite color is black. So I reordered the words, but the meaning is still the same. right? We're talking about me, we're talking about my favorite color, and we know that it's black. So with commutative property, if everything's being added or if everything's being multiplied, we can reorder things and the answer will still be the same. So 12 plus 6 gives us 18. But we could reorder that and say 6 plus 12, right? And that will still be 18. You can also do this when there's groups, okay? So if we had, let's say we're multiplying and we have 1 times 2 times 3, for example. Well, parentheses first, so 2 times 3 is 6. 6 times 1 is 6, okay? If we were to reorder, not regroup, so the grouping wherever the parentheses are is going to stay the same. It's the stuff inside the parentheses or outside that can change. So since there's not another number outside with 1 would stay there. 2 and 3 are still grouped, but we can reorder them. So instead of 2 times 3, we have 3 times 2. 3 times 2 is 6, times 1 is 6. Okay, so this can be with parentheses, without parentheses. Basically, if everything's being added, you can do it in any order and it's the same. Or if everything's being multiplied, you can do it in any order and get the same answer. So commutative property, you're communicating. We can say things in different orders and it's the same. So commutative property is reorder. Associative property, associative property, think of who you group yourself with, like cliques. So associative property is regrouping. Okay, again, important thing with just associative property, we're not reordering things. With just commutative property, we're not regrouping. Okay, another way you could actually change this, so back to the 1 times 2 times 3 example, we don't change what's grouped, so 2 times 3 will still be the grouped one, but you could also say that reordering would be 2 times 3 times 1 instead of 1 times 2 times 3. Or you can reorder it twice, 3 times 2 times 1. And all of those will give you the same answer. Okay, hopefully the difference between those makes sense. So let's just do a quick check. I want you to look at each of these expressions. So we'll call that one number 1, 2, and 3. Look at each of those and try to identify which property is used. So properties we've talked about today are distributive, commutative, and associative. So try to identify which property is being used here, which one's being used here, which one's being used here. So pause, try that, and then come back. All right. My throat is getting dry from all this talking. Okay, we're almost done. Oh, I had another yawn. Okay. We got this. Let's look at number 1. We have 2x squared plus 4x. Now, the other version of it would be 2 times x squared plus 2x. So one thing to look for is if parentheses show up when there's not parentheses over here, generally that will be distributive property, right? Because associative property, we are regrouping, but parentheses will usually always be involved, right? We're just moving them. So this would be an example of distributive property, because if we do 2 times x squared, we get 2x squared. If we do 2 times 2x, we get 4x. All right, let's look at number 2. 2x squared plus 4x equals 4x plus 2x squared. So you'll notice the terms are the same, 2x squared, 4x, and 4x, but the order changed. So that one's distributive. This one, again, order, right? Think of order, we're communicating, so commutative. And then let's look at this one. Now again, here we have parentheses where we didn't have parentheses here. Okay, and if we were to distribute that 2, we would have 4x, and then 2x times x would be 2x squared. So that is also an example of distributive property. Tricked ya, you thought there'd be all 3 of them. Nope. Okay, so now we're going to practice. Whew. Okay. I did send a copy of the practice paper home. If you got the Monday pickup, it's the one that says multiplying polynomials at the top. Okay, and the instructions say find each product. Basically, you're just using the distributive property to simplify each of those expressions. Okay, so if you're still not sure which worksheet this is, it has problems 1 through, how many problems are there? 24 problems. Okay, yes, you do need to do all of them. And yes, you need to show your work. Again, I don't care if you use box method or the pure distribution method. Either way is fine as long as we're getting to the same answer. Okay, but you have to show your work. Okay, you're going to turn this in with the Monday drop off next week. So that'll be the 28th. So the 28th is when you're going to turn that in. If you don't want to wait that long, you think you're going to lose it or something, you can take a picture and email it to me. Okay, or if like you're quarantined so you can't leave the house and you can't spread germs with papers and stuff, you can take a picture of it and email it to me. That's totally fine. Okay, so you need to do all of them. You need to show your work. You'll notice that when you're going through these problems that almost all the examples we did with the distributive method, so the box method and distribution method, so example A, B, C, D, and the 2 try this problems, those are actually problems from the worksheet. So you already have 6 of those problems done. Okay, so really you just need to copy what you did back onto the paper. Okay, so 6 of the problems are already done. So really you only have 18 problems to do by yourself. Okay, now if you have any questions at all while you were working on this, please, pretty please with a cherry on top, message me on Google Hangouts. It's by far the fastest way to get a hold of me because it comes straight to my phone. I get like the instant notification. Okay, if you don't want to do that, you can email me, but that gets to me a lot slower. Okay. Okay, so you're going to do that whole practice. Now, my guess is it's going to take us Monday and Tuesday to get through all of this. So whenever we finish, and if we have enough time, Tuesday, we'll do this Tuesday, but if we don't, we'll do it Wednesday. So if you're an online student or you're sick or quarantined at home or something, and you're doing the online stuff for a couple weeks, we're going to be playing bingo with these answers and you can win some candy. Okay, so if you want to join us for that, just as a little fun bonus with this, it'll probably be Tuesday or Wednesday. I'll let you know for sure. Monday after class, kind of to see how far we get. But it'll probably be Tuesday or Wednesday. I'll announce on Google Classroom when that's going to be. So you could join us live, like we can Google Meet you in with a computer and you can play bingo with us. Okay, so it's going to be on that assignment. We're using those answers to play bingo when we're done solving all those problems. Okay, so message me on Google Hangouts if you have any problems. I know that was a lot of information, so hopefully you took some breaks. Hopefully it made sense. Please, please, please let me know if you have any questions. Wow, all of that was on 1, 2, 3, 4, 5, 6, 7, 8, 6, 17. I lost track. I lost track of the number of slides. Not very many slides for all of that information. So if you want to like take a screenshot of this, actually, what I'll do is I'll actually save this screenshot right here and post it, because that I think will be really helpful to look back at later. So I'll do that. I'll post that. But feel free to watch the video over and over again if you need to. Okay. All right. Awesome job today. I know that was a lot, so fantastic job for sticking with it. You all rock.